Hi, I'm Rod, and in today's video, we're going to be working on a high-efficiency dust hood for the table saw. Stay tuned. Dust is a constant battle in my shop and most wood shops. One of the biggest offenders is the table saw. This tool's used extensively every day, and the factory dust ports do a mediocre job, in most cases, of getting the dust out of the air. I found that in my shop, the vast majority of cutting done with the table saw are rip cuts in 3/4 inch material that were under 2 inches wide. The solution I came up with was a dust hood that attached to the rip fence. It has a flap that moves up out of the way so that it can be moved for larger sheet goods. Far and away the most intricate part of the build is the clear acrylic face. The main face part and 2 tilting blade covers were cut from a single 18 by 24 sheet of 1/4 inch thick acrylic. There was enough material to make 2 of the tilting blade covers. I went ahead and made 2 because I can see this part wearing out or getting damaged over time. The parts were cut on a CNC router set to a high travel speed and low RPM. This can certainly be done with more traditional tools like a jigsaw and a drill. I'll leave a link in the comments below for a scalable drawing of the clear acrylic face. The acrylic needs to be bent at a 90-degree angle. It could also be cut into 2 pieces and glued together, but I prefer the cleaner method of bending the acrylic. I used a shop-built acrylic bending jig. There are a lot of tutorials on how to build one of these very easily with a piece of resistance wire, so I'll leave that up to those videos. The wooden parts that need to be cut are fairly straightforward. I use 3/4 inch red oak, but only because that's what I happen to have lying around. Any 3/4 inch hardwood's going to work just fine. Now that the basic pieces are cut, there's one other component that we need to address before we begin assembly. The acrylic blade flap is going to be held down with a thumb screw. That thumb screw needs a stable set of threads to screw into. To accommodate this, I used a 1 inch by 4 inch piece of the 3/4 inch oak. That's going to provide a base for the threaded insert. After drilling and placing the threaded insert, it was bolted to the bottom of the top board, out of the way of the blade. To start the assembly, we attach the top board to the acrylic face with some number 6 by 3/4 inch wood screws. We need to be sure the screw heads are below the surface of the acrylic. That allows the blade flap to lift up without obstruction. The baseboard assembly is attached to the acrylic face with number 6 by 1.5 inch screws in the back and number 10 by 1 1/4 in the front, making sure to place the right angle aluminum in front of the acrylic plate before we put the screws in. The back support needs to be attached to the baseboard 2 inches from the end of the board with some number 6 by 1.5 inch screws. That allows enough room on the baseboard for the rear mounting bolt and the threaded knob. The filler strip is then attached alongside the back support with number 6 by 1.5 inch screws. The next step is to attach the dust port to the acrylic face. I used a 4-inch round flange dust port found at any woodworking supply store. I used 3/4 inch long machine screws with washers, lock washers, and nuts to attach the dust port to the acrylic face. To make the port channel on the fence side of the hood, I used a 20-inch slice of 14-inch wide light gauge galvanized metal roof flashing. There needs to be a crease on about a 20-degree angle near one side. I created this using a sheet metal brake, but you could also clamp a couple of boards or a couple of pieces of right angle steel together and fold the crease easily enough that way. Using a pair of pliers, sheet metal pliers are ideal if you have them. Flatten the crease back out on one end of the metal, perpendicular to the seam and at least an inch from the edge. Mounting the sheet metal to the hood requires using some form of clamping strips. I used the 3/4 inch by 1 inch strips of wood, but metal bar stock or aluminum bar stock would work just fine. The lengths are listed here. I placed the sheet metal on the fence side of the hood so the crease in the metal meets the angle in the acrylic face below the dust port. I secured it with a few screws in the clamping strip, making sure the metal extended beyond the edges of the hood. At this point, I formed the metal into a cone shape and marked where it meets the edges of the dust hood. I cut the metal with a pair of 10 steps along the lines that we just marked, and then filed the edges so they weren't sharp. I then attached it to the dust hood using the clamping strips. I used some silicone sealer where the metal met the acrylic to fill in any gaps and eliminate any air loss. With the main part of the dust hood assembled, I attached the blade flap with a 1/4 inch by 1 inch bolt using a lock nut through the front hole, and a 1/4 inch by 1 inch thumb screw in the rear hole, tightening it against the threaded insert we put in earlier. I mounted the dust hood to the fence by placing it on the fence and marking it for the 1/4 inch thumb screws. Once they were drilled, T-bolts were placed into the fence and tightened with threaded knobs. I used a Y connector to split the dust collection between the factory port on the bottom of the saw and the new port on the dust collection hood we just installed. The blade flap can be tilted up and out of the way to slide the fence by loosening the thumb screw. Since using the new dust hood, the difference has been tremendous. With the factory setup, I estimate about 50% of the dust was making it into the dust collector. With the new setup, I estimate 90% of the dust is being collected. I hope you found this project useful. Please like, subscribe, and share your comments below. Thanks for watching.